Lesson 2, Basic Geometric Constructions. Your learning targets for this lesson are to be able to construct and measure segments, midpoints, angles, and angle bisectors. You'll be able to use midpoints and segments to solve real-world problems, and you should be able to name and classify different kinds of angles. The vocabulary for the first part of this video be coordinate, distance, length, congruent segments, construction, between, midpoint, bisect, and segment bisector. Let's start with a postulate. Remember that postulates are statements that we consider true without proof that tell us about the properties of geometry. The points on a line can be put into a one-to-one correspondence with the real numbers. The best example would be to think of a ruler like a line. Each mark on the ruler represents a location or a coordinate, a point on a line. The distance between any two points is the absolute value of the difference between those coordinates. Let me show you an example. If we have 2 points, A and B, and A is located, as we see here, at 2, and B is at 5, the absolute value or length of the segment AB would be the absolute value of 2 minus 5, which is 3, or 5 minus 2, which is also 3. Thus, we can find the distance between any 2 points. You try. You might want to pause the video and work the problem before I show the answer. Did you find that xy was 3.5 units and zx was 4.5? Remember that z is at -3, so that when you are subtracting 1.5, you get a -4 1/2. But since you take the absolute value, your distance will still be positive. Any two segments that are congruent if they have the same length. We have a little bit of an odd thing that we do in math. We define simple words like between. Betweenness describes the location of points. A point B is said to lie between 2 points, A and C, if A, B, and C are on the same line, and if A, B, the segment, plus the segment BC equals the entire segment AC. This gives us the segment addition postulate, 1, 2, 2. It states that if B is between A and C, then AB plus BC equals AC. An example of using this postulate to solve problems would be that given B is between A and C, and AC is 14, and BC is 11.4, we want to find AB. First thing we would do is use the postulate to make an equation. We know that AC is the entire length of the segment, so it goes on the left. It is equal to AB plus BC. Then we just substitute in the values that we were given. AC is 14, so that goes here. AB is what we're trying to find, so we just label it AB. And BC is 11.4, so we can substitute that in. Then subtracting the 11.4 from both sides, we get that AB is 2.6. Another example would be an algebraic approach. If we are given segment lengths with algebraic expressions like 2x plus 7 is RS and ST is 28, and then we're told that the entire segment RT is equal to 4x. We want to find RT, what the actual number would be. So we can substitute in the values we were given and make an equation. 4x equals 2x plus 7 plus 28. Simplifying, we get that x equals 17.5. Since RT is equal to 4x, we multiply 17.5 times 4, and we get 70. So our total length would be 70. You give it a try. Pause the recording so that you have time to work out the two problems before I show the answer. Did you find that YZ was 1 2/3 and that DF is 24? Some additional terms we want to make sure that we understand are construction, midpoint, and segment bisector. Construction is a way of creating a figure that is precise in measurement, and we use compasses and straight edges for this. You want to make sure that you understand a description when you read a math problem so that you can construct a model for yourself. This gives you a guide to refer to solve problems. A midpoint is the point that divides a segment into two congruent segments. It's the middle point. The segment bisector would be the thing that intersects that point. It might be a ray, a segment, or a line. It intersects a given segment at its midpoint and divides that segment into two equal parts. Let's look at an application problem. The map shows the route for a race. You are 365 meters from drink station R and 2 kilometers from drink station S. The first aid station is located at the midpoint of the two drink stations. How far are you from the first aid station? If we let our current location be labeled a point X, and we know that to the next drink station we have 365 meters, and then it tells us that from drink station R to drink station S is a segment, and that Y, which is our first aid station, is the midpoint. That would mean that RY is equal to YS. The entire distance from where you are to the last drink station is 2 kilometers. Let's think of how to solve this. We know that XS, the entire length, is equal to XR, the part we know, plus RS. We know that we're 365 meters away. RS we need to find. We don't know what that distance is. But we know that we're 2 kilometers, which is 2,000 meters away from S. We could subtract the 365 on both sides, and we get that RS is equal to 1,635 meters. So this whole segment is 1,635. We know that we only want to go halfway of that segment to the first aid station. So we divide this in half. 1,635 divided by 2 gives us 817.5 meters. Then we make a new equation. We want to know exactly how far we are. So xy. xy is equal to xr plus ry. So we add those two values together, and we find that we are 1,182.5 meters away from the first aid station. Do you see how much easier it is to solve if you take time and draw a picture, any kind of diagram, so that you can see exactly what the problem is saying? For part 2, your vocabulary words are angle, vertex, interior of an angle, exterior of an angle, measure, degree, acute angle, right angle, obtuse angle, straight angle, congruent angles, and angle bisector. It's a lot of words, but they fit together nicely. First of all, we should define what an angle is. An angle is a figure that's formed by two rays, or two sides, that has the same endpoint. If we look at the diagram, we have RS and RT. These are two rays that share the point R. This is the vertex. The set of all the points between the sides, or inside the angle, are in the interior. I always try to keep interior in mind when I think of an interior decorator. They decorate the inside of the house. So the interior is the points inside the angle. The exterior of an angle is the set of all the points that are outside, or the blue part here. Thinking of, we decorate the exterior at holiday time. We name angles by letters, by all 3 points in the angle that are labeled, such as SRT or TRS. We can call it by its vertex if there is only one angle, or we might number an angle. This would be angle 1. The protractor postulate 131, it says, given that line AB and a point O on AB, all rays that can be drawn from O can be put into a 1-to-1 correspondence with the real numbers from O to 180. The measure of an angle is usually given in degrees. Since there are 360 degrees in a circle, 1 degree is 1/360th of that circle. When we use a protractor to measure, it's very important that we know what kind of angle we're measuring. We can classify them by their size. An acute angle is any angle that is measuring greater than 0 degrees, which means it at least exists, and less than 90. So angle COA would be an acute angle. When we look at the protractor, you see that you have 2 rows of numbers. You have a large row on the outside. Going from left to right, they increase. And you have a row of smaller numbers from right to left getting larger. Which set do you use to measure this angle? Well, since this is an acute angle, that means it must be less than 90 degrees. So we would take the smaller arc of numbers. This angle would be about 45 degrees. A right angle measures exactly 90 degrees. This is made by perpendicular lines. Any angle that measures greater than 90 degrees but less than 180 degrees is called an obtuse angle. Angle DOA is an obtuse angle. When we look at the protractor, we know it has to be greater than 90 degrees. We would not use the smaller numbers outside the circle. We would use the larger angles. This angle measures 115 degrees. The other kind of angle we need to remember is the straight angle. It is formed by two opposite rays, and it measures 180 degrees. In other words, it's a line that has a point. All lines are straight angles, and they measure 180 degrees. We have an angle addition postulate, which is postulate 132. It is much like the segment addition postulate. It simply states that if we have an angle RQS and an angle SQP, then if we add them together, their measures will equal the measure of angle RQP. That makes sense. It's just adding two angles together, you get a bigger angle. Using this with an example, we have a drawing off to the side over here. Anytime that you are given a statement like this, it can be confusing. Draw yourself a picture. This will help you solve the problem. So we are told that angle ABD is 37 degrees, and angle ABC, this whole angle, is 84 degrees. We want to find angle DBC. Well, we know that ABD plus DBC equals the entire angle because they're connected. So we make an equation. The entire angle is 84 degrees. We know that this is equal to the 37 degrees of ABD plus DBC. We don't know what DBC is, so we simply write measure of that angle. We subtract the 37 from both sides, and then we come up with an answer. Measure of angle DBC is equal to 47 degrees. You try it. Go ahead and pause the recording so that you can have time to work it out before I show you the answer. Did you get that angle YWZ is 62 degrees? Good job. Angle bisectors are rays that divide an angle into two congruent angles. Congruent angles, just like congruent segments, are angles that have the same measure. So we can think of a bisector as an angle as a ray that cuts an angle right in half. You can use the bisector to solve measurement problems. For example, we're given this statement that BD bisects angle ABC. So we have ABC here, and we know that BD bisects it. This means that ABD is the same size as DBC. They're equal. If we're given how much the two angles, the two smaller angles, equal in degrees, ABD is 6x plus 3 degrees, and DBC is 8x minus 7 degrees. We want to find the actual measure of ABD. First of all, we have to find what x equals. So we can set the two angles equal to each other because they are formed with an angle bisector. We're going to add 7 to both sides, subtract the 6x from both sides, divide by 2, and we find that x equals 5. Since we know that ABD is equal to 6x plus 3, we just substitute the 5 into the equation, and we get that ABD is equal to 33 degrees. Here are two problems for you to try. Since there are no pictures, try drawing a diagram. Make sure that you draw PQR as your large angle. From the vertex Q, you'll make a bisector in the middle, QS. Then label the two sides. PQS is 5y minus 1 degree, and PQR will be 8y plus 12 degrees. We want to find the measurement of PQS. Go ahead and stop the video so you can work out the two problems. Did you find that the measure of angle PQS was 34 degrees? And the measure of LJM was 46 degrees? Good job. Make sure that you've taken your notes using the Cornell method. Write all your key points and summary. Review the example problems so you'll be ready to construct segments, segment bisectors, find some segment lengths, construct angles, angle bisectors, and find the measurement of angles in class.